All right, what's good, y'all? Link here. Let's go for another daily legal question. Question 2200. Find all k-distance indices in an array. Easy one with 77% acceptance rate. Let's see how this one goes. 2200. Let's see. Let me grab the code. Okay. So we have a list and two integers. You're given a zero index integer array, nums, and two integers key and k. A k-distance index is an index I of nums for which there exists at least one index j such that the absolute value of the difference between those indices is less than or equal to k, and nums index j is equal to the key. Okay, so k this is an index of nums which there exists at least one index j such that, okay, so we have a j can be either after or before, and then the distance between the I and j has been less than or equal to k, and then the nums index j has to be equal to the okay. Okay, so from what I understand now, I'll whiteboard this thing real quick. So we have an array, we have I right here, and then we have a distance k right here, right? And then we need to have some element in here that is equal to the key, right? I think that's pretty much what we're saying over here. Return a list of all k distant indices sorted in increasing order. Okay, let's see. So key is equals to 9, k is equal, oh, okay. So I guess in this case we have 9, and then we have 4. Let's see. Uh, do, 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 do. Let's see. So we have key is equal to 9, so 4, 1, 3, 5. Oh, are we returning the indexes? Oh, in the indices. Okay. Okay. So in this case, we're turning this less than or equal to k. Okay. Now, okay. Does 9 count as a k index, distant index? I think it does. So if I do this, we have everything except for 0. 0, 1, 2, 3, 4, 5, 6. Yep. But we don't, of course, we don't want to repeat anything. Oh, let's see. Okay. Yeah, the first thing that I noticed here is that it has to be all of them because we only need to check every single element once. Now let me think. Um, mm, let's see. Feel like we can do kinda like a using like a prefix. So let's see. Mm, Let me take a screenshot of this one so we can whiteboard. Okay, so in this case we have 3491395. Yeah, so my first thought on this one would be, okay, let's grab all the keys in the nums array, and then from each key we can move outwards, both to the left, both to the right, and then grab a single number. But that in the worst case, we're gonna go over the array multiple times, right? Which is not good. that's not a good idea. And then my second idea would be, okay, so let's go three, let's go one by one, and then kind of like having an like an array accumulator, accumulate all the numbers that we currently have. So in this case, we would have three, and then we would have four. Boom, we have nine. So let's see. Okay, so we will have an array. Let's see, we have an array that accumulates everything. So that in this case, we'll accumulate three, four. Once we get to a nine, we add that index. Okay, so we can accumulate all the numbers, and once we get to the nine, well, what if we don't have it? In this case, we have three, we have four. Oh, but k is equal to one, right? So let's do. Okay, so let's get the index of the first nine, which is 0, 1, 2. So current key index is equal to 2, and then we start from 0, and then for each element, yeah, for each element, we check if the index is within k. So in this case, we have 0. If 0 minus the absolute value of this, 0 minus 2, which is 2 in this case, is less than or equal to k, boom, add 1. Otherwise, we don't. We go with 2 now, check. Oh, 2 is good, boom, add 2. Now we 0, 1, 2. Sorry, 0, 1, 1 is good, bam, add 1. Now 2, we are at 9. So we update the current index, current key index. Therefore, check if we are good. We are good. Send. Boom. 1. Check if we're good. We good. Boom. 3. We're not good. Now we found a 9. Oh, that's the problem now. Because, yeah, that's a problem now. Why? Because now we want to have 3, but 3 was too far from this 9, but it's closer to this 9. So I guess we can do the same thing on the other direction, right? And then we add to a set. And I'm pretty sure the set is gonna be ordered. So in this case, we will get, let's see. So from left to right, right, we would have 0. 1 is good, 2 is good, 3 is good, and then 4 would not be good, and then 5 is good, and then 6 is good, is good. And then from right to left, we will have uh 5 is good, no, 6 is good, 5 is good, 4 is good, 3 is not good, 2 is good, 1 is good, 0 is not good. And then we have 1, 2, 3 missing the 4, 5, 6, and now have 1, 2 missing the 3, 4, 5, 6. So at the end, at the result, we will have 1, 2, 3, 4, 5, 6. There you go. Yep. Thinking that should work. We're going twice from left to the right, and then right to the left, adding everything to the set of the result. Okay. Now that I'm thinking, yeah, we can actually start with the index as negative infinity, and because that won't ever be the a valid distance until we find the 9. So in this case, 3 will be invalid. Let's do again instead of let's do negative infinity. So with negative infinity, we will have from left to right not, no, 0, 1, 2 will be good, 3 will be good, 4 is not going to be good, 5 is going to be good, and then 6 is going to be good. Now from right to left, we're going to have, okay, so 5 is not going to be good, 9 will be good, oh, sorry, 6, 5 will be good, 5 will be good, 4 will be good, 3 is not going to be good, 2 will be good, 1 will be good, 0, no. And then as a result, we're going to have 1, 2, 3, 4, 5, 6. Yep, 1, 2, 3. Yeah, I think that should work. Let's see. Um, okay, so we have result, which is equal to a set current index. Current key index is equal to, let's do infinity, and then we can have infinity is equal to 10 to the power 10. Okay, and then let's do left to right, and then we have right to left. Okay, so for I, uh, so let's see. Once we, so that will be not good. That's not good. Once we get the key that we want, boom, we update. So we kind of want to update before we check everything. Okay, so for I in range, let's do blah, 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 and is equal to the length of nums. For I in range of n, we're doing left to right. So if nums index I is equal to the key, then current key index is equal to I. And then if the absolute value of I minus current key is less than or equal to k, then res.add, right? Yes. That means that the current index is valid. And then we do the same thing, but from n minus 1, negative 1, negative 1. Oops. Okay, so we go from left to right. If the number index I is equal to the key, we update the current index. And then if the I minus the current key index, the absolute value of that, the distance between me and the current key that we found, if that's less than or equal to k, then we get to the result. And then we keep going doing that. And then the next for loop, we're gonna go in the opposite way. So from right to left, if the number in x is equal to the key, then key, we're going to update the index for the key, and then we check if the absolute value of the difference is less than or equal to k. If it is, add to the result. And since it's the set, we won't have to worry about duplicate keys. And then at the end, we can just return a list of the response. I think that should be it. Let's see. Yep, pretty good. Let's give it a submit. See how this one goes. Yep, there you go. Okay, wasn't actually that bad. Kind of like a DP, like a double DP, because I remember I had a question that I had to do pretty much the same thing. I think was it the candy one? Balance give you the candy to the kids or something. I don't remember, but I remember there was this one dynamic program question that I had to go from left to right, but then I also had to go from right to left to make sure the answer was right. Yeah, wasn't actually that bad for this one. So yeah, I think that's all I have for this one. Appreciate y'all for watching and see you guys next time.